Hello and welcome to what will be the final actual lesson in the Advanced C# course. And in this lesson I want to take one step further from the previous lesson where we began to introduce the concept of the task parallel library. And I want to take that to the next step into one of the new more popular features of C# 5.0, and that is the async and await keywords. And oftentimes you're going to see these things mentioned together. And yes, they are very similar things, but they have a fundamental difference in that the task parallel library is just that it's a library, it's functionality, it's code that is built into the framework to allow you to create tasks and do asynchronous programming without having to directly interact with threads. Now, async and await is a construct of the C# language that helps us to interact with that task parallel library a little bit more fluently from within the language as opposed to having to dig too deeply into the library itself. So let's go ahead and work through an example in some code and I'll show you exactly what I'm talking about. Alright, so here we are once again back in Visual Studio, but this time I'm going to switch it up a little bit, and as you've clearly recognized within this entire course, I've created a lot of console applications because those allow me to really write up some examples very quickly and give you some output very quickly. But in this lesson, I really want you to see where some of the benefit of this task parallel library and the async and await keywords really come. And to do that, I want to create a very simple UI. Now, this can work in Windows applications, it can work in web applications. It doesn't really matter, but what the end goal ultimately when you're creating a UI for the user is you want a very good user experience. You don't want the user to do some sort of activity and have to sit there and wait for it to end and have a UI that's unresponsive. Those things are a big turnoff to your customers and to your clients. You want to be able to give them a very immersive experience that allows them to do multiple things at the same time without bogging down your application and making it very clunky. So what I'm going to do first is I'm going to create a new project. And in this case, instead of creating a console application, I'm going to select Windows Forms application. Now, I will admit that I will never be confused for a UI designer, so I'm just going to throw together a very quick form here so that you can at least get the idea of what we're trying to do here. So I'm going to put a button on my form, and I'm going to make it a little bit larger so everything is very easy to see. And I'm also going to put a label on here. So really the ultimate goal here is I want to push my button and I want something to happen to that label. So I want to be able to write something out to that label. So I'm going to go into my properties of my label here, and I'm going to increase the font just a little bit so it's easier to see. So we'll say 15. All right, that should be good. So we'll save that. There we go. That's beautiful. So now what I want to do is every time the user clicks that button, I want some operation to happen and then give a response to the customer in the form of something popping up in this label. So to do that, I'm going to double click on this button 1, which behind the scenes is going to create a delegate and an event, and it's going to create this button 1 underscore click, which is ultimately going to be the method that is going to be executed once that click button is observed or subscribed to. And if you don't understand events, you can go back to the events lesson where I kind of go into this in a little bit more detail because I'm not going to go over it in quite as much detail here. So what I want to do once I've clicked this button, I want to do some sort of operation. So I'm going to create a private method here. It's going to return a string, and we're going to call this big long important method. And it's going to take in a string and it's going to take in a name. So now what we want to do within this method is it's going to simulate that there's a lot of work going on. So I'm going to once again throw in this concept of a thread sleep. So I'm going to add in the system.threading namespace. So I'm going to do a thread.sleep, and I'm going to have it sleep for about 2 seconds, which is 2,000 milliseconds. And then I'm going to have it return hello, comma, name. There we go. Seems like a lot of very difficult work. All right, so now what I want to happen once the user clicks this button, I want this operation to happen and then give some sort of response back to the customer. So now all I really want to do is I want to take that label that I put on my form and set its text property equal to the result of this big long important method, and I'm going to pass in John, just like this. So now I'm going to hit F5 and you can see the application comes up. And now when I click this button, I can't do anything else. I can't click anywhere. Oh, see, it finally came back, but there's definitely some stall going on there, and I couldn't even move my form around. It wasn't responding, and that's a very common problem when you start working with UIs, when you really want to do some very intensive operations that are very CPU intensive, but then it winds up blocking your UI and you're not able to really do anything, and oftentimes the screen will go translucent and it's a really bad experience for the customer. So it's definitely something you don't want to do. So now that we've seen what you don't want to do, let's start to take some of the things we've learned in the previous lesson with tasks and the task parallel library and see if we can improve this user experience a little bit. So ultimately what we want to do is we want to update that labels text property with the result of this method. So let's see how we can do this in the form of a task. So what I want to do is I'm going to create a task just like I've done in the previous examples, and I'm going to do that via the task.factory.startNew method. And if you don't know what this is, take a look at the previous lesson and watch it for a few minutes and you'll come up to speed very quickly. I assure you, it's not a very difficult concept. And I want to pass into this a lambda expression of what it is I want to do. And what I want to do is I ultimately want to call this big, long, important method, and I want to pass to it, let's pass to it something different this time. We'll pass to it Sally. And so now I've created this task, and remember that start new creates a new task and executes it immediately. And now once that's done, I want to do something with that. And once again, if you remember from the previous lesson, the way that you execute some sort of task, once this task is done, is you can chain onto it continue with methods. So I'm going to do that right now. I'll do continue with. And now it wants a reference to the task that is previously completed. So in this case, I'll just call that T, and then I'll give it our little lambda operator. And now what I want to do within this task, once the previous one is completed, I want to update my label one.text equal to something. Now what is that something? Well, in the previous lesson, I did not quite go over this, but in this lesson, it's going to be much more important. So once that previous task has completed, this start new operation in here, I need the result of this big, long, important method. And the way that I get a hold of the result of that method is via the task object that was created by it. Now, as you notice here, I didn't save that task, but the input into this continue with, as you can see here, it is a delegate, and the result of that previous operation, since we're chaining these things together, is a task, and it gets pushed into this continue with method as T. And so now if I want to access the result of that previous operation, all I need to do is access the result property from that task. So now once I've done that, I can close off this continue with, I can save and build, and as you can see, everything succeeds. Now I can hit F5, my form starts up, and I can click my button, and now it's responsive. I can do things, but as you'll see here in a moment, we're going to fail. And that's because it's saying that this is a cross-thread operation, so I am not allowed to update my UI from a thread that is not the main UI thread. Now, if you've ever done any sort of UI programming or anything within Windows or any other language for that matter, you know that this is a big no-no and you're not allowed to do it. So there's a lot of constructs in the system.threading namespace to allow you to check to see what thread you're on, and then you can switch back and forth between them. But there's a lot of overhead that comes along with that to have to do that checking constantly. Well, within the task parallel library, there's actually a very simple way for us to check for that and actually have a task run on really whatever sort of context we want to, and that's done via the task scheduler class. Now, if we take a look at the continue with method here, and I do a comma and I check out the IntelliSense, if I jump down here to overloads, you're going to see that we can pass in a task scheduler. Now, if I take a look at the task scheduler class, you can see that there are a couple different properties and a method here, current default and from current synchronization context. Now, what the task scheduler tells this task is from what context do you want me to run? So by default, all of these tasks are going to be running in the background. They're going to be running asynchronously, but what I can choose to do via this task scheduler is specify where I want it to run from. So if I use the from current synchronization context method, it's going to take a look at my code, take a look at my application, and see where I'm calling from and run this particular task that's embodied within this continue with method and run it within that context, which in our case happens to be the main UI thread. So now if I save this and I hit F5, I can now click my button, I can move my form around, it is all responsive, and yes, I get this label updated. So now you can see we've started to we started to get our functionality to execute properly, as well as give us a nice responsive UI. And that's always something that is better than a non-responsive UI. So now we don't need this commented outline anymore. So now, yes, we've had to add in a little bit of code here to get this whole thing to work, but really it's not too bad. And once you play around with this whole TPL a little bit, it becomes a little bit more natural. So now that we're able to do this via the task parallel library, what about this async and await stuff? You've been hearing about it a lot. What does it allow us to do? If you've done any work with task parallel library, you've probably written something like this in your code somewhere, whether it's for your UI or for in a service or something like that, and you don't want to throw this away. You've already done this work, and if your business logic is already embedded in there, you really don't want to have to rework it to do some other sort of library or some other language construct. So you would typically just leave this here because it will work just fine, and we're simply going to build this async and await functionality, this asynchronous functionality on top of it. So once again, as I mentioned before, async and await is merely just a language construct that allows us to interact with this task parallel library and chaining these continuous statements without actually having to do that so much. We can start to just decorate our code a little bit with these keywords, and a lot of things are done behind the scenes for us. So let's take a look at how that works. So the first thing that I would do when I was trying to transform my code into a more async and await friendly asynchronous programming model way, I would start to take the code that does the majority of my logic, and in this case that happens to be this big long important method, and I would start to write a wrapper around this to allow me to use my async and await keywords to get at this functionality. And there's one simple thing that we need to do in order to really enable us to do that, and we're going to create a private method on top of this, but in this case I wanted to return a task because at the end of the day I want to be able to execute this method and be given a task back so that I know that this is running somewhere, and whenever it's done I can figure that out, but I don't really care. I don't need it to finish now. I can continue going about my business. And so the first thing I'm going to do is I'm going to transform this return type of string into a task string, which this means simply that I'm going to execute this method, but it's going to return me a task, and then once that task is completed, I can access its result property and then use that string that's embedded in there. And I'm going to call this big, long, important method, and this is more of a convention type thing in which we name our methods that we are typically going to have run asynchronously. We typically append the word async onto the end of it. And it's going to take in the same parameter as our big long important method does. And all this is going to do is it's going to return a task.factory.startNew, and then it's going to take in as its action the lambda expression of big long important method, and we'll pass in name. So there we go. That's all our asynchronous method here is going to do. That's all that it's really required to do. So now we need to wire up our button click event to kind of handle this new way of doing our operation. So I'm going to comment this out temporarily. And now what I want to do when this button is clicked, I want it to execute this big long important method async, but I want to see how I use my async and await keyword. So the way that we do that is we write ourselves a method, and async is really just a way to decorate your method signature to inform the runtime and the compiler that this is a method that may or may not contain an await keyword. And all await is the way of specifying that this particular task that the await keyword is decorating needs to complete before I can continue to go on in my functionality. So I'm going to specify async here, and we'll simply call this call big important method. There we go. And I forgot my return type here, which is going to be void. And now you're going to see that I have some squigglies here because it sees that we have the async keyword in the method signature, but we don't have an await in the method. Now this is merely a warning. This is okay, but you really need to, if you're going to use this keyword, you should really have it there for a reason. So we could build this and it will succeed, but we're not using this to its full capacity, because like I said before, async doesn't actually do anything. It's merely a decorator to allow the runtime and the compiler to know that there should be an await in this method. So now how do we use that? Well, we are going to run our functionality. We're going to say var result is equal to, and we are going to await our big, long, important method async. And we're going to pass in, this time we're going to pass in a different name altogether. We'll call it Andrew. So now as you can see here, we are simply calling our big, long, important method async with our await keyword to say, aha, once the execution comes into this method, once I reach this line, I cannot continue beyond this line until this has completed. And once this is completed, what do I want to do? Well, as in the previous examples, I really just want to update my label text to be equal to result. So now you can see a little bit differently. I'm not so worried about the continue statement. I'm not worried about keeping a track of the task that was completed and accessing its result property to get things from the previous task, and trying to specify that this needs to be running on the current synchronization context so I can update my UI. These are a lot of the nice little features that these await and async keywords allow us to do, is to bypass some of that other stuff, because it's going to handle all of that handshaking back and forth between what's on the main UI thread, what's not on the main UI thread, is something in the background, is this running on a new thread? That is all going to be handled behind the scenes for us. So all we have to focus on is our business logic. So finally, all I'm going to do is I'm going to come in here and I'm going to execute my call big important method like such. And now I can save this and I can build. And if you wanted to get fancy, you could even put a little update of your label in here just to say that something is actually happening and I'm waiting for a response. So we'll save this. So now if I hit F5, and now our form is opened up. Now if I click my button, you're going to see, I'm waiting and I'm responsive. I can do all this stuff, and we get our hello Andrew message back. So now you can see that there's definitely a couple different ways to get at this asynchronous UI updating programming. You can definitely do it in the old style via the system.threading namespace and doing some sort of that manual synchronization. You could definitely do it using the TPL and being able to chain together a few continuous statements, as long as you remember that you're going to have to, if you need to update your UI, you're going to have to use your task scheduler to specify that you want to do it from the current synchronization context, which, as I mentioned before, merely means that I want you to update it from the main UI thread. Or you can start to put together these async and await type operations in this way. So if I were to get rid of this line and you weren't even aware that this existed, none of this looks too crazy, with the exception of maybe that you do see a task in here. And the only reason we're doing that is so that this is explicitly being done within the background, and I'm not going to block the UI. But other than that, this really just at the end of the day looks like some normal code that you would write every single day. There's really no extra things being done here that seems strange to figure out what context I'm in. Am I on the main UI thread? Am I not? Because all of that stuff via the async and await keyword and tasks are being handled for us behind the scenes. So this async and await stuff is definitely very cool. It is definitely worth your attention, and I really believe that this is going to be the future of asynchronous programming in the .NET framework and C# for quite some time to come. So thank you for joining me in this lesson, and I hope you can put this to use tomorrow.